All right, so this is the first video I'm making for pre-calculus. This is going to be some review, some very basic review, and I also am going to post this video for my calculus class as well. I give the same review for both classes because I just want to go over some absolute basic ground material to make sure that we are sort of all on the same page with some essential ideas. This is at once both very basic and also like super abstract. So this is kind of a fun lesson for me, and it begins with numbers. All right, so this being a math class, we're going to be dealing with numbers. Not all math classes deal with numbers, but pre-calculus and calculus certainly do. And in particular, we're going to be dealing with numbers in a continuum. So what I mean by that is the real number system, which is represented by this symbol R. Okay, so real numbers include a number of things. First, they include integers, which are numbers like 0, 1, 2, 3, -1, -2, so on. So let's see. In our continuum here, which I've drawn as like a number line, somewhere in here we're going to have 0, and somewhere we'll have 1, and then somewhere we'll have, like back here, somewhere we'll have -1. So positive numbers on the right, negative numbers on the left. So yes, our real numbers include integers. And for integers, by the way, the symbol Z represents that set of all integers. Okay, so we have those. But we also have rational numbers. Rational numbers, the word rational comes from the word ratio, which has to do with fractions, right? A fraction is like a ratio of two numbers. So rational numbers are the set of all fractions of integers. So that's going to include, well, actually, it's going to include all the integers themselves, because you can always take an integer divided by 1, and that equals itself. So those are all technically also rational numbers. But of course, we're going to have things like 1/2 and 3/2 over here, and whatever. And then we're going to get, you can keep cutting in half, and you can cut in thirds and all kinds of things. So we can break down very, very far, okay? We can break this down really far into fractions, ever smaller and smaller fractions. So those are all our rational numbers. That does a lot to fill in this number line. That fills in much of the gap between the integers. And the set symbol for rational numbers, by the way, is Q here. But that is not all. We also have irrational numbers. Irrational numbers are the real numbers that are not rational. There's no particular set symbol for them. And they are kind of weird, but also very abundant. In fact, in some ways, there's more irrational numbers than there are rational numbers in the continuum. And that includes numbers like, probably the first one that comes to mind for many people would be the number pi. It's a famous irrational number. But another number we'll work with a lot in calculus and pre-calculus is the number e. And one of my favorites is the square root of 2. Okay, so these are just some examples of irrational numbers. Irrational numbers are kind of hard to put your finger on. They're just certainly hard to write down because their decimal expansion goes on forever and never repeats. So technically they're impossible to write down in some way other than with a symbol. Yeah. So these are all different real numbers, and I want you to understand that they form this nice continuous number line, which you can imagine something moving back and forth through this number line very smoothly. Now, part of the reason we use the continuum is because it's very practical. It sort of describes the way space works. When you move around, like if I move my finger back and forth across here, you can see that I'm not moving my finger in little steps, right? It's not like I'm jumping from one position to the next position. I'm moving smoothly and continuously through space, right? Through this space we live in. Space is continuous. And so if we want to use mathematics to describe reality and try to model it so that we can, make predictions and, design things, then it makes sense to use a continuous number system because our reality is continuous, right? So, okay, that's the kind of space we're going to be working in. This is one-dimensional, but we're going to be working in two-dimensional, and I might talk a little bit about three-dimensional as well at some point. Algebra. Okay, we're going to be dealing with geometry, we're going to be dealing with algebra. And in algebra, numbers can be different things. We can have constants, like 0, 2, pi, etc. Okay? A lot of our numbers we work with are going to be constants. They can be variables. Common variables, of course, are x and y. Also t for time. Those are some really common variables. Or numbers can be algebraic expressions. We're going to go over the algebraic operations in a minute here, but algebraic expressions, things like 2x plus 1 squared, right? Something like that is an example of an algebraic expression. That's still a number. And for all intents and purposes, we will treat that as a number. It's going to follow all the same rules that numbers follow. One more thing on the end here is function outputs. And for pre-calculus, we're not going to talk about functions for a little while. We're going to spend our first unit talking about equations and not really dealing with functions, but later we will, so I'll kind of bring it up here. If you have a function called f, the output of that function from either a variable or a constant input, the output of that function is a number. And so we treat it like a number. You can add it to things, you can subtract it from things, you can talk about its inverse or its opposite or whatever. So f of x is a number. Notably, f by itself is not a number. Okay, so I'm not saying here that the function f is a number. I'm saying f of x is a number. Right? So another example would be like logarithms. Log is a function. Log is not a number, but log of x is a number, or like log of 2 is a number. Trigonometric functions like sine, cosine, and tangent, those are functions, so their outputs are numbers.